Hello students, welcome back to the classroom point. In our today's class, we are going to discuss about the atomic models. So we shall begin the class. In our previous class, we had discussed the discovery of the subatomic particles. They are electron, proton and neutron. These three particles together called as the subatomic particles. So after the discovery of the subatomic particles, so it becomes a question. There was a confusion among the scientists that where do these particles exist in the atom and what is the interior structure of the atom. So to establish the structure of the atom, various scientists have come forward. Again, they proposed different type of the atomic models. Among these atomic models, the first atomic model was Thomson atomic model. So according to the Thomson atomic model, he assumed that atom is a sphere of positive charge. That means atom is spherical in shape and it is completely, whatever the positive charge is there, the entire positive charge is uniformly distributed throughout the atom, or it is a sphere of positive charge. And electrons are present here and there, means different places of this positive charge. Just like how the seeds of the watermelon are embedded in the red part of the watermelon, so that it is resembling the model of the watermelon. Hence, it is also known as the plum pudding model or raisin pudding model, or else watermelon model. Then here he said that these electrons, what is the advantage of this atomic model is, wherever these electrons are present, these electrons, anyhow that we know that electrons carry the negative charge and remaining protons carry the positive charge. So these electrons neutralize the positive charge that surrounds them. So like this, he was able to explain the electrical neutrality of the atom. Electrical neutrality in the sense, atoms do not carry any charge, only ions carry the charge. So as these electrons are neutralizing the positive charge present around them, so finally the entire positive charge is neutralized by the electron, so that there is no net charge present on the atom. That is what called the electrical neutrality. This is the only advantage, but Thomson atomic model failed in explaining the mainly two things. Their stability of the atom. These electrons, as the electrons are negative charge, they repel each other. Once they repel each other, they may go out of the atom, or else they may destabilize the atom. So that stability of the atom was not explained. Stability of atom was not explained by the Thomson. And one more, hydrogen spectrum, also not explained by the Thomson. But still we do study the Thomson atomic model. The only advantage of Thomson atomic model is had given the shape of the atom, that is spherical in shape. Still we consider the shape of the atom as a spherical in shape. Now let's come to the next atomic model, that is Rutherford alpha scattering experiment, where alpha stands for helium nuclei or doubly ionized helium atoms. He2 plus is known as the helium nuclei. We know that helium atomic number is 2, electronic configuration is 1s2. If both the electrons are removed, then only nucleus of the helium is present. That gives the He2 plus now. So He2 plus is known as the alpha particles, and alpha particles carry the positive charge. Now coming to the Rutherford alpha scattering experiment. So let us have the discussion about the description of this experiment first of all. In this experiment there is a lead box which contains the radioactive substance, maybe either polonium or radium. So this radioactive substance is able to release the alpha particles. So alpha particles comes out of this lead box. When these alpha particles are allowed through the small slit, so they go in the straight lines. When this gold foil is not present, only when zinc sulfide screen is present, these alpha particles go in the straight line and hit the screen directly. And whenever the charged particles hit the zinc sulfide screen, zinc sulfide is a fluorescence material. So whenever charged particles hit the zinc sulfide screen, it produces the tiny flashes. So zinc sulfide gives the fluorescence effect, not the material, it gives the fluorescence effect. So that here tiny flashes are observed. When gold foil is placed in the mid of the path of the alpha particles, that means now alpha particles are hitting the gold foil. What is the purpose of selecting only gold foil? Why gold atom is selected? We know that metal is highly malleable, can be converted into the very thin sheets, approximately 10 power minus 4 millimeter thickness, so that we can clearly get the one atomic radius of the, or one atomic thickness of the gold sheet. So very thin gold foil was placed. So when alpha particles are allowed to hit the gold foil, then scattering observed like this. Then here this diagram again, here we have drawn that, we have taken the only single gold atom. Now from this diagram what we can get information is, as Thomson said, if the entire atom is filled with positive charge, then no alpha particle should have passed through the gold foil. All alpha particles has to bounce back. So from that, the atom is not completely filled with the positive charge. Now coming to this diagram. So whenever alpha particles are allowed to hit the gold foil, Rutherford observed that most of the alpha particles passed through the atom without any deviation. That is first observation. Second observation is, some alpha particles deviated by some angles whose angle is less than 90 degrees. But some alpha particles deviated with more angles and only one alpha particle exactly bounced back. These are the three observations. So from this the conclusion is, since most of the alpha particles passed through the atom without any deviation, so he said that the positive charge, as he said Thomson, is not uniformly distributed throughout the atom and most of the space in the atom is empty. And some alpha particles deviated by making some angles. You can see here three alpha particles. Imagine this is a 1, 2, 3. I'll give this one numbering 1, 2, 3. So when we see these alpha particles, the angle here, theta, whatever is there, this theta is less than 90 degrees. But the theta value gradually increases. And whenever you see where the alpha particles are located, see this alpha particle is making less angle, and this alpha particle is making little more angle, and this alpha particle still making the more angle, means greater than the 90 degrees. So this concludes that we know that alpha particles are carrying the positive charge. So whenever the positive charge particles are moving like this, imagine here also some positive charge is present. When alpha particles, positive charged particles are moving very much away from the opposite positive charge, then they go little, they will make the little angle, Again, if you see, whenever the alpha particles are approaching close to this positive charge, then obviously they get the more repulsion, so that they make the more angle. And the alpha particle which comes very close to the positive charge, they get the more repulsion, even more than the earlier one, so that they make the larger angles. And the alpha particle which tried to hit the positive charge exactly bounced back with 180 degrees angle. So here one alpha particle bounced back with 180 degrees angle. So from this he observed that, as Thomson said, the positive charge is not uniformly distributed, but the entire positive charge is concentrated at the center part of the atom, which he named as the nucleus. So Rutherford alpha scattering experiment first discovered the presence of the nucleus, and he said that we know protons carry the positive charge, so that the nucleus contains the protons. But when protons are present within the smallest area of the atom, all protons, since they carry the same charge, obviously they repel each other. So to keep the nucleus stable, some other type of the neutral particles are required, which acts as a gum between the two opposite charges. They reduce the repulsion among the same charged particles, so that he said, along with the protons, neutrons also present in the nucleus. Since protons and neutrons are present in the nucleus, these two are called as the nucleons. And we know that only protons and neutrons carry the mass, electrons do not carry the mass. Electrons are regarded as the massless particles. Since only all protons and neutrons are present within the nucleus and they are carrying the mass, that means whatever the mass of the atom is there, the entire mass of the atom is coming only from the nucleus. So nucleus is known as the densest part of the atom. And based on these observations, he proposed the atomic model. According to the Rutherford, the center part of the atom is known as the nucleus, that contains both the protons and neutrons, and it carries the positive charge. The positive charge is plus Z into E. E means charge, Z means atomic number. When the number of protons increase, charge of the nucleus also increases. And electrons revolve around the nucleus in the circular paths. They are called as the orbits. So imagine the electron is moving in the circular path around the nucleus. So these are called as the orbits. Again, there is an electrostatic attraction force between the electron and the nucleus that keeps the atom stable. So these are the three observations and three proposed models what he has given. But there is a drawback in that proposal only. As he said, there is an electrostatic attraction force between the electron and the nucleus. And he also said that electrons are revolving around the nucleus in the circular path. So this represents the planetary model, solar system. That's why it is also known as the planetary model. Now coming to the point, as Rutherford said, if there is an electrostatic attraction force and electrons if revolving under the influence of the opposite charge, that is positive charge, that means they are in the acceleration. According to the Maxwell's electromagnetic theory, any charged particle which is moving under the influence of the opposite charge will continuously lose energy in the form of the radiation. So that electron also has to lose the energy in the form of the radiation. When it is losing the energy in the form of the radiation, its orbit radius gradually decreases, and finally the electron will spiral down into the nucleus. And for electron, it takes only just 10 power minus 8 seconds to spiral down into the nucleus. That means within 10 power minus 8 seconds, electron will lose all of its energy and finally fall down into the nucleus. When electrons fall down into the nucleus, atom will destroy. But atoms are stable. So that was not explained by the Rutherford. And one more thing here is, he was not able to explain the hydrogen spectrum also. Why different lines of the hydrogen spectrum is coming, that concept also was not explained by the Rutherford. Now coming to the planetary model, we know that planets revolve around the sun. Here electrons revolve around the nucleus. Why solar system is stable? Why atomic structure, atomic model according to the Rutherford is unstable? Here both the nucleus and the electron are carrying the charge. These are the charged particles. But planets are not charged particles, so that there is no chance to lose the energy. Now, apart from that, what other information he has given about the both nucleus and the atom? Based on the means where these particles are striking, certain area was not struck by the alpha particles, because in that area more dense nucleus part is there, so which is not allowing the alpha particles to hit the screen. So this area here, actually zinc sulfide screen is there, so they are not hitting the screen. So based on that, he was able to give the radius of nucleus as 10 power minus 15 meters. And radius of the atom given as 10 power minus 10 meters. So when you see this one, atom is 10 power 5 times more larger than the nucleus, or nucleus is 10 power 5. Nucleus is 10 power 5 times smaller than the atom. That means nucleus is 1 lakh times. So small that if you imagine the nucleus as a cricket ball, then the atom can be imagined as its radius can be imagined as 5 kilometers. So imagine how the atom, how much powerful the nucleus is and how it is controlling the entire atom. So that much power the nucleus usually generates. Size of the nucleus can be calculated. Or radius of the nucleus can be calculated for other atoms as radius is directly proportional to the a power 1 by 3. Or else we can give the constant value, that constant value 1.33 into 10 power minus 15 a power 1 by 3 meters, where a equals to atomic mass. And we know that 10 power minus 15 is equals to 1 Fermi. That's why this value can be written as in Fermis, R equals to 1.33 a power 1 by 3 Fermi. Now the question is, what happens instead of the gold foil if you take the heavier metals? If heavier metals are taken, when heavier metals are taken, then the scattering angles increases. So when the metallic atomic number decreases, scattering decreases. When metallic atomic number increases, automatically scattering angles also increase. So from this, Chadwick concluded that atomic number is directly proportional to the number of protons present in the nucleus. So dear students, I hope you understand this class. We shall meet in the next class. Thank you.